Hi, welcome to the System Biology Software session. I'm Ting-Chao. My topic is the pharmacodynamic algorithm for integrated assessment and ranking for multiple candidate drugs by computer simulation. My talk is divided into 4 parts, from theory to design to experimental protocol to example of application in vitro, in animal, and in clinical trials. It is not possible to present it in 5 minutes. Later, please look at the individual slides and specific references. Now I just quickly glance through the slides for the remaining time. For the theory, the median effect equation for general theory, the combination index equation for calculating synergism or antagonism, and the dose reduction index equation for calculating dose reduction in synergy situations. The unified theory is the mass action law, which is the median effect equation, also called the doctrine of the median. The median effect plot linearizes the dose effect curve of different shapes and different potencies. This is the algorithm for the PD analysis and the synergy determinations. Computing software allows automated simulation for the MAL pharmacodynamic and CI plot. The computing is for free download at the Composing website. Computing generates 4 diagnostic plot, FACI plot, isobologram, normalized isobol for determining synergism or antagonism, and DRI plot for the dose reduction in synergy. The article introducing the MLPD and CI theory has over 7,000 citations in 1,300 biomedical journals internationally. Among the 10 different methods for synergy determination, CI method is by far most popular due to the fact it is the only quantitative method with automated computer simulation. Now move on to the design. I recommend 2 drug combinations at constant ratio using diagonal design. It is most efficient. For example, the ACT and the interferon combination in vitro using only 16 dose data points allow complete simulation of synergism. This slide compares the design of 2 drug combinations in vitro, in animal, and in clinical trial in terms of time and effort, cost, sample size, and feasibility. Now move on to applications. In vitro, this is the taxol cisplatin and topotecan 2 and 3 drug combinations design and analysis against colon carcinoma tumor cells. The results show the CI value smaller than 1 indicating synergism and DRI greater than 1 indicate dose reduction for synergy. These are anti-HIV 2 to 5 drug combinations. The results allow ranking of all single drugs and their combinations under the same PD principle and the same conditions. In vivo, this is a 2 drug combination against colon carcinoma xenograft in nude mice that use only 10 dose data points, each dose using 6 mice. The computer-generated diagnostic plot include the dose rate curve, FACI plot, isobologram, and FADRI plot. These are the summary of results. The CI and DRI values are calculated on different days after drug treatment. For the anti-HIV clinical trial in literature, ACT plus VTC used 366 patients, but not valid to claim synergism due to incorrect PD design and only the p-value for data analysis. By contrast, the AZT interferon trials use only 36 patients, yet quantitatively determine synergy using the Chou and Talalay CI method. This is the proposed anti-COVID-19 design for 2 and 3 drug combination integrated method in vitro and in clinical trials using the unified MAL-PD CI simulation. These are immunosuppressant combination for synergy determination in vitro, also in animal for the kidney and heart organ transplantations. These are the website for references. Thank you for your listening.